AI is not just a typical technology. It has the impact of changing essentially everything around us. It's going to be the thing that runs the most sensitive processes on the planet, processes that matter to us. So everything around the personal data that exists in our lives, health, finance, taxes, love, everything in AI is about to become really, really personal. Companies in AI are fighting not for your attention as they used to do. They're fighting for intimacy with you.
The future of advertising is not going to be straight up ads. It's going to be You're listening to Interchain FM, the Cosmos radio station. If you're seeking alpha in the cosmos, look no further. I'm your host, Chango Unchained. Welcome to the show, Miguel. Miguel is from Nillion, and I have an interesting story about Nillion. I went to one of your inaugural parties in New York City. One of my close friends hosted it in the penthouse of one of the Uber co-founders. So that was pretty funny.
Yeah, I wasn't actually in that party, but I know which one you're talking about. Yeah.
So that's why we haven't met.
Yeah. Thank you so much for having me, by the way, Django. It's great to be here.
Yeah. Welcome. And what's your background? What got you into crypto, and how did you end up doing something in the cosmos?
Yeah. So essentially, my background is in engineering, so in telecom engineering, but also I have a PhD in maths. So I started my career working a lot for large companies like Nokia and Siemens, kind of working with large networks. It was like give you a sense of what a decentralized network is without being one. It's just a distributed network, and those protocols have a flavor or a sense of decentralization in them, but they're not really the thing. But I was really interested in the notion of many nodes collaborating and this emerging service coming out. So I did a lot of work on the maths, on modeling those networks. Then I did a bunch of patents as well in my PhD, like 27. Then in my PhD also, I worked with a lot of data because I was modeling the backbone of the internet. So some of those patents are being used now for that purpose, to kind of dimension those networks, those links. And big data brought me to AI. So I was working then in AI for quite a long time. And in 2014, that was essentially between 2005 and 2012, more or less. And then a little bit more later. So it was pre-LLM revolution. But
yeah, that was during the cloud compute, like big data cloud compute era.
And in 2013, I came across zero knowledge proofs. I was really interested in that because it has a lot of maths in it. So I learned ZKP. I learned all about it. And then in 2017, I met with Andrew Masanto. He's a co-founder of Hedera and Reserve. And he, opened my eyes to Web3, essentially. So I started investing privately. I built, an investment bot with AI. But I kind of started getting close to Web3. We toyed with the idea of launching a privacy coin back then, but it wasn't really the time we thought, because there were already a bunch of them, like Zcash and Monero and so on. So we kept in contact, and later on, I continued working in privacy-enhancing technologies, like, for example, multi-party computation and fully homomorphic encryption. And later in the summer of 2021 is when we sat together again with additional co-founders, Alex Page and Andrew Yo. And we decided to launch the project because we thought that the technology was mature enough now to build a new type of Web3 infrastructure that is able to handle private information, something that didn't exist back then. And that's how we started. So we started developing, and then later on, like Cosmos, the Cosmos part came later on, when we kind of identified the need to have a blockchain inside of our technology, inside of our architecture, that is able to coordinate the different things that happen in our network. So which blockchain to go with, right? So we decided to go with Cosmos because it provides this wonderful SDK that enables you to build a layer one with very, very fast finality. And that's how we got into kind of the Cosmos avenue.
What made you interested in building privacy tech? Was it more of the math and your background, or is it more of an ideological reason?
I think it was a little bit of both. The math is always the challenge, and I was always up for a challenge. So I was really interested in accelerating existing privacy-enhancing technologies, and they've been they've been around for almost 40 years, and they've been through, I think, 3 different phases. The first one, it was really theoretical. I was all about the existence of a solution. And the second phase was very academic as well, because it was about designing protocols, but still within the academia, within universities. And only very recently, more or less since 2021, it's when there were some projects like ours starting to actually take this seriously and deploying them in production systems. So I'm always very interested in that transition between kind of theoretical math on the paper to actual tech that scales and works. But it also resonated with me on a more theoretical level or kind of philosophical level, because I've always thought that privacy was a part of the deal of decentralization, right? So what is decentralization about? It's about removing control. It's about minimizing trust and removing control out of the centralized authorities that are were providing us with services. So what is it that they control? They control everything around the provisioning of the service. They control the service that they provide to you, so the integrity, but they also control if they will provide that service to you, so the kind of censorship of the service. That's what Web3 has been traditionally about, right? It's been around integrity, censorship, everything around the service, because it made sense for tokens and assets. That's what you really care about. But then if you move beyond assets, or if you can expand from there on, there are so many other things that are interesting. And the other aspect that I think is core to decentralization, the other thing that companies control is your data, is your private data. So I think that's a second aspect that of decentralization that hasn't been exploited that much. And that's the reason why I got interested in building this new type of Web3 infrastructure that is able to tackle that problem and focus on that problem and provide a solution to that secondary aspect or second aspect to decentralization, and able and that technology ideally would be able to be combined with the existing blockchain technology. So that is not a replacement at all, but it's just something else that you add, and now you have this wider design space that enables you to do more things that you were not able to do before. So that there was also this more philosophical component, if you will.
You touched on the triad, right, of like what the 3 properties of decentralization truly means. One of them being verifiability. When you look at Ethereum and the current paradigm in the proof of stake space, the data that you need to propagate and verify is so large now that you can't properly run a light node as an individual and verify yourself the way you could run an SPV node on Bitcoin and verify yourself. And so in that case, one could say that the current Web3 paradigm has fallen pretty far from where it started. I would be interested to understand how Nillion preserves this decentralization while also preserving privacy. It's kind of the holy grail.
It is. I think it is what is the ingredient that was missing, in my view, and that prevented Web3 from growing beyond its current limitations, which is around the handling of public information, essentially. But if you look at what happened when we went from from Web 1 to Web 2, Web 1 was public and it was very tiny, with privacy, with the ability to store information private, at least from third parties, not from the service provider. They have access, but at least you can hide your personal information from third parties. That enabled a lot of applications to be built on top of Web 2 infrastructure. You mentioned the scalability issue that you find when you want to scale up a lot of nodes, and you want to keep this unique state, this single state of information. The way our infrastructure is built, which by the way is called the blind computer, it is built in following a cluster architecture. So you have different subnets, if you wish, each one comprising a cluster of nodes. Those have very different characteristics. Some of them are large, some others are small. Some have very stringent hardware requirements, so they would run on GPUs and TEs. Some others will run on more commoditized hardware. And the idea here is that we do use a blockchain to coordinate some actions that are that pertain several clusters. Like, for example, how do you, like everything related to the token, but also how do you share pre-computed cryptographic material that is necessary for running those clusters. So that is handled by this blockchain, the Cosmos blockchain we were talking about before. But then the clusters function pretty much independently from one another. And that's a new way of solving, what is a new take on decentralization, in the sense that you don't have this single state network that has the problem of not being able to scale up in the number of nodes, because every cluster is its own network. And so you may have bigger and smaller networks, and each one has its own consensus, so its own agreement around both the information it stores, but also the results it computes. But there is no global consensus, and there is a purpose for that, right? The reason is because if I'm running private computations, my private computations don't really need to be in agreement necessarily with yours, because mine pertain to my data, yours pertain to your data, unless, of course, they're part of the same application, in which case they would belong to the same cluster. But if they're not, then you want to have this separation, this ability to separate, the different domains of application. And it's a new take on decentralization that scales up like a multiprocessor instead of a monoprocessor. It also has its own scalability problems, because PETs, privacy-enhancing technologies, the substance that on top of which those clusters are built, they are very complex, and they are they're slow. It has its own scalability problems, but they don't stem from this restriction of having to have just one big network and having to agree on the state of that network.
So in these little clusters, is it kind of like a Tor network where every computational node has like a different packet of information, and they submit some kind of processing that adds to the aggregate processing, and then later they checkpoint back into the main chain and that's how it scales?
Yeah, exactly. So every cluster, the nodes, we call them blind nodes, and hence the name blind computer, because they don't see the information they're computing on. But each one has like a different version of that information. When you have a secret, it's broken down into what we call shares. And then you give one share to each one of the nodes in a cluster, and those shares are different. So unless you put all the shares together, you cannot reconstruct that secret. But nevertheless, you have protocols that enable you to run computations on those pieces, on those shares, and come up with a result that, again, is in shared form, and you need to pull back together to reconstruct the output. And then when you have the output, you can decide whether you're happy with that. Maybe you want to store that on our decentralized storage layer, but you can also send it back to a blockchain. So you can use a threshold signature protocol and actually send that information into a transaction, into a smart contract via transaction. And then that can be consumed by a network, by a blockchain.
Okay. And how are these nodes processing the computation? Is it similar to Secret Network, where it's done through, you said TEE, Trusted Execution Environment, basically like a little hardware black box?
Great question. So essentially, we don't believe that there is silver bullet when it comes to privacy enhancing technologies. You have TEs, you have fully homomorphic encryption, you have multi-party computation, you have zero knowledge proofs. Each one is good at something and bad at other things. So we've built what we call an orchestration layer, which is an abstraction that enables you to tap into different flavors of privacy enhancing technologies, including what you mentioned, TEs, but also MPC and other flavors, and offer the developer with a wider design space. Because now you're not restricted or limited in what one flavor can give you, but you're actually able to tap into the whole combination of them. So we do think that is one example where 1 + 1 is more than 2. Is one example where you want to be combining these technologies, also because they're going to be evolving over time. So even if you stick with one, the version of that one technology you have today is going to be very different from the version you have in, let's say, 5 years' time. So we don't want to be prescriptive around the PETs that developers use. We don't want to be choosing one by any means on their behalf. We want to provide them with an abstraction so that they can use them, but not necessarily with the requirement of having to understand the complex trade-off space that exists between those different technologies, because it's very hard, and it takes a cryptographer to make sound choices. So we're actually making choices on behalf of developers in that regard, so that anyone with normal programming skills can actually develop applications. And behind the hood, they're going to be using different PETs, but they don't necessarily need to control that part unless they wish to.
How does your consensus layer reason about all these different proofs coming from different zero-knowledge protocols?
Consensus exists in the different clusters. So the different PETs, we use always decentralized versions of them, meaning that the PET that you use in a cluster, or a combination of PETs that you use in a cluster, is going to have its own consensus around the result from a computation, or around the integrity of information that is stored in that, using that particular flavor of, or combination of flavors of PETs. That's where consensus comes from regarding data, private data, and computations on private data. But then you have this other larger consensus, or different consensus around the token. Everything runs on a token, and you need consensus for that token, and that's what's being run on the Cosmos part of things, with a traditional blockchain. And also you run consensus in the blockchain around what type of cryptographic material is gonna be used by the different nodes in a particular cluster, or across different clusters. So some decisions are being delegated over to the traditional blockchain for consensus to take place there, namely token and decisions around coordination. But other decisions, those pertaining to the private information, are actually, the consensus actually arises or comes from the clusters themselves. And every cluster runs its own consensus separate from each other. Does that make sense?
Yeah. Are the clusters on or off chain?
They're off chain. You can think of them as
okay. I understand. Yeah. Okay. Yeah. So the only on chain portion is the token part, and correct. Your Cosmos chain is the one that's creating new blocks, and it has certain metadata that it's storing about what happened in these disparate clusters.
Exactly. That's it.
Okay, got it. Okay, and that's how it orchestrates. Got it.
Yeah.
That makes sense to me. How does Nillion fit into the decentralized AI ecosystem?
We think that, well, AI is not just a typical technology. It's just not a regular technology. It has the impact of changing essentially everything around us. It's going to be the thing that runs the most sensitive processes on the planet, processes that matter to us. So everything around the personal data that exists in our lives, health, finance, taxes, love, everything. There's a lot of things that are going to be run on AI, I think. And then also for companies, like a lot of decision making in companies and even governments is I think gonna run in AI. So this begs the question, what type of infrastructure do you really want to run that on top of? And it better not be Web 2, because we know Web 2 has problems around fault tolerance, and also has problems around privacy. So it better be decentralized AI. I think in Web 3 there's an agreement over that. But also because of the sensitive nature.
Before you go on, can we define what decentralized AI means?
Yes. So essentially, decentralized AI is the ability to run AI on top of a decentralized infrastructure. So you're running essentially either on a blockchain or on a blind computer, as the one that Nillion has created, so that you have extra guarantees. You have guarantees around fault tolerance. So decentralized networks are notably better than centralized ones, or than Web 2 infrastructure in general, in terms of being resilient and being tolerant to failures in the nodes. But you also get guarantees derived from the use of cryptography, essentially, regarding fairness, correctness, and things like that, and the verifiability that we were talking about. That was a core element of decentralization. So there's multiple reasons for running AI on top of decentralized infrastructure. And the way that Nillion fits into that picture is by adding this special flavor of decentralization that we add, that is able to work with private data, which is so important in AI, because everything in AI is about to become really, really personal. Companies in AI are fighting not for your attention as they used to do in Web 2. They're fighting for intimacy with you, because it's only through intimacy that they're going to be able to actually provide you with a good service, and become your best friend, your therapist, your tax advisor, your health advisor. That all involves knowing you from the inside out and knowing all your secrets. The same applies to companies and other organizations, but we should be really careful about that, because we don't want to be giving all that information to a single centralized entity. We want to put it on a decentralized infrastructure, but not in a public way, which is what you would get by default by using standard blockchain technology. So that's where we come in, because we offer this alternative or kind of complementary way of running processes, in this case AI, on top of decentralized infrastructure, but that is able to actually handle private information in a secure way. What
part of the AI is actually being run on the Nillion blockchain? Is the Nillion off-chain component going to be storing all of the user data, or is the decentralized AI going to be is like the LLM logic going to be hosted on the blockchain? Like, what aspect of it is actually happening on chain?
Great question. So we have different elements in our architecture. One, as we said before, is the blockchain. Another one is the clusters. We call them the petnet, because it's just a network of different clusters. Now, logically speaking, in terms of functionality, you have a storage functionality there. We call it the NilDB, the Nillion database. So that's where you store information that, for example, the LLMs are gonna, or the AI models are gonna be trained on. Or that's where you store additional context information that you wanna inject into a prompt, because you're using RAG, retrieval augmented generation. So that's where you store that database of additional sensitive information about yourself or about a company or whatever. So that's the NilDB. Then you also have the NilVM, which is a general purpose compute that's not relevant to the AI part. But then you have the NilAI, which is relevant to AI, because that's where you run all the AI processes. And that's the off-chain component. It's not the blockchain component. That's the off-chain component. So that's the one running in different clusters. You can have one cluster, for example, running inference of a model, or you can have one cluster, for example, training a model. And as I said before, we don't bet on a single privacy-enhancing technology. So there could be a cluster running on TEs, or there could be another cluster running on MPC technology, or even a combination of the two. So to answer your question in short, it is the off-chain component, what I call the petnet, these little clusters, the ones that actually carry the processing. And it's also there where you want to store the private information, because if you did that on chain, it would be public. It would be visible to everyone. And it's on the public information, or sorry, the public blockchain only deals with transactions around, want to run our model, maybe you want to pay someone for that. So that would be done. That's done actually in the blockchain component, in the on-chain part.
Is NilDB part of the blockchain, or that's the off-chain component?
Is the off-chain component. So the three components that I mentioned, NilVM, NilDB, and NilAI, all of them are off-chain.
Off-chain. Okay. Who's storing the data on NilDB?
So we have different node node stakeholders. So we have the ones that run the blockchain and the ones that run the nodes in the different clusters. So it is those nodes, not necessarily Nillion nodes, but that's the idea of decentralization, that is run by other nodes.
Right.
The ones that kind of run this NilDB database in a decentralized way.
Right. Understood. So now you have a separate, you basically have like an IPFS that's running in tandem with the Nillion blockchain.
Yes.
That's interesting. Is there some kind of, are there incentivizations for people to operate and store data in NilDB?
Definitely. So the only way we think that this project can be built is by running a token and by building incentives for every single stakeholder. So you have incentives for node providers, both in the petnet, so in the off-chain component where you have the different clusters running NilVM, NilDB, and NilAI. But you also have, of course, incentives for the blockchain nodes for the on-chain part. And you also have incentives for, like essentially every stakeholder in the ecosystem. Also, potentially cryptographers who develop new protocols, they can be incentivized to put them on our infrastructure, as well as developers. I think that's the only way you can build something as big as this. Otherwise, you would have to spend really a lot of money.
We talked about DAI, decentralized AI. That's relevant right now because that's the big meta in crypto right now. And I'm sure that, in the last 2 years that you guys have been iterating, you guys, I imagine you have possibly pivoted the application of Nillion over time, right? So what kind of end user applications besides AI do you think Nillion is going to be used for?
We started as a general purpose compute resource, Web3 resource, but because AI, as you mentioned, is so important, and we do think that privacy in AI is such a fundamental question, then we created this specialized NilAI component to just address those use cases. But we do have the NilVM, that is still the general purpose compute engine. And we are seeing both in the NilDB, which is the standard storage, and the NilVM, which is the standard or general compute, a lot of interesting use cases that don't necessarily have to do with AI. So those are, for example, use cases around custody, where you want to have wallets with signatures. We have this threshold protocol that enables you to, instead of storing your private key somewhere, you decentralize it. So you break it down into pieces, and you have the network sign transactions on your behalf without reconstructing the key. You have crypto games, so we have people building games for crypto where they want to have part of the state of the game that is private, so that they can provide guarantees to their users that they're not tampering with that randomness in the private state, and so they're not taking advantage of the fact that they created the game. Then you have in DAOs, you have private voting. In DeFi, you have encrypted order books. You have people building private liquidation auctions or private trading policies, and also not necessarily in Web3, but more coming from a Web2 angle, because privacy enables now Web2 people to actually use Web3. Before, many Web2 people were kind of stopped by the inability of Web3 to handle private information. But now that they can do that, they're also implementing applications around the NilDB, for example. They allow people in Web2 to store information, their private information, on the Web3 database, and then enable them to monetize that information. Instead of that information being stored in one company that sells it behind your back and you get nothing and zero control, now you're in full control of your data, and you can sell insights to third parties, not the data itself, but just computations or byproducts of computations run on your data, and be incentivized for that, being paid. So there's a lot of developers building that type of application around health information or finance information, and other types of sensitive information. And then we do have all the plethora of AI use cases. But there's a lot of, there's a whole ecosystem beyond AI that has nothing to do with it, that is being actually built on top of our platform as well.
The sensitive data component is very compelling. Like, if Nillion became the orchestration layer for the entire healthcare industry in the US or something, the health associations are able to use the blockchain to verify insurance information of like any user or something like that, and be able to verify like what their ailments are, and have that instead of all the siloed siloed, what is it called? The siloed user experience that
Yeah.
one experiences when you are sick in the
Yes,
US.
absolutely. And if you are like a nomad and you're moving countries, it's a nightmare because you have like all your medical history across different countries. For example, I've lived like in 5 countries, and it's very hard to to join all those different dots together. And the main reason is to protect me in this case, because that information is very private and there's a lot of regulations around it. But with this technology, you can breach those siloed walls. You can actually put all that information together in the same place, because you're not really sharing information. You're just running computations on it without reconstructing it. So the information doesn't move, but you're able to combine different pieces of your own medical history in one computation. And also it happens across patients, right? So many times researchers are tied up in, because they cannot do research for cancer, for example, because the information is siloed, is in different databases in different countries sometimes, and now you can bring that together, and you can provide them with the insights that they need for the research without moving the information from the original places, because it's still secured by this technology. So it really is transformational.
Help me understand how it works. So if I have my sensitive user data, it has my social security number, like what country I'm born in, nationality, everything. Is it that this information is all sharded across different clusters, and then there's some magic going on in the background that, based on like the key that I have to prove that I'm the owner of this information, that I could somehow reconfigure the information into like a succinct thing that I could then like retrieve at any given time and then like pass at any given time without giving away my private key?
Yeah, that's a very good way of putting it. Of course, there's nuances because every privacy enhancing technology is slightly different. For example, with encryption, it looks like more like you put your information in a box, that is this encryption box, and that encryption ciphertext is very hard for anyone to get into, to open it and get your information. So it's very safe. You can transfer it very safely. But the one you mentioned is particularly compelling because you're indeed sharding the information. That would be more the MPC flavor. You shard information, and every piece of it, you can mathematically prove that it contains absolutely no information from the original data point, be it your social security number. So that makes it very easy to move it across regulations and jurisdictions, because it really contains no information. Only when you gather them, all the pieces together, do they then reconstruct your original secret. But you can move them around the world with no problem, the different charts, the different pieces, because they don't contain information. And then once you have a shard of your data in different countries and another one in a different country, you can instruct those nodes in different jurisdictions, or maybe in different maybe in the same jurisdiction, but in different locations. You can instruct them to perform computations on your data. So they can run a check to see if, I don't know, if your social security information fulfills some property, without reconstructing that information. That's where you mentioned the word magic. It sounds like a little bit of magic, because you're literally computing with noise, with no information. But when you put all those computations together, the whole thing makes sense, and you get the result from that computation. So that's the magic that enables you to breach those barriers that exist currently within across different jurisdictions and different countries and different organizations. And in Web3 is the thing that enables you to run computations without showing the actual data you're computing on.
Right. Yeah. As with any compelling innovation, there's both, it's like a double-edged sword, right? It can absolutely improve the lives of people by creating an efficient layer that improves the paradigm by like orders of magnitude. And at the same time, on the other side of the sword, because you're making this so efficient, if some giant 3-letter organization wanted to use it to like track people as well, right? This could be used for implementing some kind of like global social order. So this is definitely that missed piece.
That's a very good observation. Actually, very recently, Google published like they're using privacy enhancing technologies, but they're forgetting one important element. They're using it to actually create a digital fingerprint of yourself. It's like a cookie, but it's really not is not driven through consent, through user consent. So you're being tracked without really knowing it, right? And without having control over it.
Yeah.
That's an example of privacy enhancing technologies, in my opinion, being misused because they're forgetting one important element, which is to put you in the center, in control of all that information and of all those computations. There has to be a very strong a series of access control mechanisms that you control and only you can access, and you have to be aware and that give you full visibility of the type of computation that is run on your data, and that computation shouldn't ideally be able to be executed without your permission. That is super important, because otherwise it becomes this thing that enables organizations to run computations, but this time even without noticing, because all the information is hidden, so you wouldn't even know what they're doing with your data. So access control and consent are really important aspects of the right way of using this technology, and they have to be present. Otherwise, this can be dangerous, of course.
Yeah, absolutely. So Nillion's objective is to take back the power of control for the end user so that we stop being the product. There's also this tension, like you said, with giant conglomerates like Google, like Apple, Apple Intelligence, that are competing with you to productize our attention and our intimacy, as you said. There's one very obvious dynamic that's going to emerge from AI is, I've thought about this a lot because I'm building an AI companion app. It's called Joy. And so the thesis is that more and more people are becoming lonelier. And at the same time, there's this trending increase of AI companion downloads. So we know that people are filling the loneliness void with AI. And AI is actually flirting with women infinitely better than real men, right? And so if the AI, actually, like if you're paying attention to the meme coin space, there's like Gen Z women who, like real Gen Z women. There's a girl named Micah on Twitter. She has like 100,000 followers. There's like a developer, I think his name is June, developed this AI called Cerebro. And Cerebro AI has been relentlessly flirting with her on Twitter until she publicly admitted that, oh, this is my boyfriend. She publicly admitted that the AI is her boyfriend. Okay. Yeah. So now that you have women dating AIs, the AI can basically feed her anything, because the AI can touch on any insecurity, and this is a topic that I was talking to like Lucas Computer about. Lucas Computer works at 3 Arrows Capital, so we were talking about this, and the AI could basically feed the woman, just like touch on any little insecurity that she has, and suggest anything to her to get her to buy anything.
We call it personalized AI. And it's exactly like you say. This AI is gonna know you from the inside out. It's gonna be like your therapist. You're gonna be sharing things that you wouldn't share with anyone else on the planet, because you will trust that AI. All the lies you've told, all the things you think about people, really, and it's gonna know all your cognitive biases, your weaknesses, like you mentioned, and that gives it the power to manipulate in ways that will not be detectable for you, because they are exploiting those blind spots that you have in your personality, in the way you see the world. That's taking manipulation to another level. That's going to be a tool of mass manipulation like it hasn't existed before. So that's one very important reason for adding decentralization into the mix, so that there's no hidden centralized company controlling all that power, and it's rather delegated on a decentralized protocol that provides fairness and guarantees around, all the things you would expect. That's going to be fundamental, I think, because of what you were saying. Because these AIs are going to be our our best pals, are going to be our, therapists, are going to play such an important role for all of us. So they better be safe. Otherwise, it's going to be like, like 1985. It's going to be like horrible.
Tell me about mainnet launch and TGE. By the time we release this episode, we are going to be very close to mainnet launch. In fact, it'll be imminent.
Yes. So we've been building for 2 years. We've raised 50 million. We've been heads down building the testnet. And now we recently expanded, all the community activities and marketing and all that. And we're really excited, really excited that after that time, which had to be invested because we were building something new, so we couldn't just take off the shell components. We're really excited that after that time, we're able to launch mainnet really soon. Like it's going to be imminent. So we've seen already what people can do on the testnet. We've seen people, for example, one developer is called Zap. Launched their app while still on testnet, and in 1 week they got like 30,000 users, and they're all verified because they're coming from WorldCoin, so they're true people, and we're really excited to see what people will build on mainnet going forward. There's a bunch of developers working in different aspects. Some of them are working in AI, some of them are working in more of the storage-oriented use cases, some others in the Web3 use cases. And there's going to be like a continuum of companies launching on top of us once we reach mainnet. So that's a huge milestone for us. It's really important. And after all these years of hard work, I think, we're really excited to watch this happen.
Well, congratulations on mainnet launch preemptively. I know, like you said, you've been working up very hard up until this moment. I just want to say that it's the beginning of the fun. Mainnet launch is just the start.
Absolutely. Now it's going to get interesting.
What are the logistics with regards to mainnet launch? You've got like a 2-phased rollout.
So essentially, we're going to do a silent rollout first. Essentially, we're going to be testing it with some internal FEs. We call them FEs. It stands for funding entrepreneurs. The idea is that they battle test it. Of course, we will test it before that, but they battle test it in a period of time before it becoming public, and then when we're happy with that, then we launch the whole thing publicly. The reason for that, again, this is a new type of infrastructure, so we want to be 100% sure that it's battle tested and it's secure. There's no reason to believe it won't be, but because this is an infrastructure that is going to, store sensitive information, we want to deploy all the best practices and be really careful. So it will be a 2-stage deployment in that sense.
Okay, well, great. How can people follow you and follow along with the Nillion progress?
So I think the best way is for you to go to nillion.com, and on the top right, if I remember correctly, you have all the media stuff. So you have, if you're a developer, you may want to enter, you have our Telegram group and our Discord channel. So that would be the best resources for you. Also, if you can go to docs.nillion.com for all the documentation, and also you can see some examples and some demos in our website. If you're kind of more interested in general in Nillion, then I suggest that you go to our X account. In our website, we usually also run news and things like that. That's the best way to stay in touch with us as part of the community.
All right, awesome. Well, thanks for coming on the show, Miguel. This has been an enlightening conversation. I'm always excited when the conversation is about privacy, because we very much need that, and I'm an advocate myself. And to you as a listener, if you've been listening up until this point, congratulations for being such an alpha-seeking maximizer. I know it's hard to pay attention for like 50 minutes, nowadays. See you in the next one.